That ends our brief introduction to a huge and interesting field. I encourage you to spend some time researching sensors and transducers, as they are the eyes and ears you will use in future automation projects. It is a continuously evolving field, so it will likely be a lifetime's pursuit. Transducer design and selection is often overlooked by overextended automation engineers, who often rely heavily on the old favorites. Let's recap on what we have covered so far. Sensors, also called transducers, are devices that sense physical parameters such as position, temperature, or pressure. In most cases, the sensor outputs an analog voltage, or a digital value, that is proportional to the parameter being measured. Position sensors measure the physical position of an object. Potentiometers, variable resistors, measure angular position and give an analog output. The optical encoder, another type of position sensor, uses a slotted disc and a photosensor. The output of the optical encoder is in digital form. Linear motion can be detected with a linear motion potentiometer or a linear variable differential transformer, an LVDT. The LVDT uses a movable slug inside a special transformer. The phase and magnitude of the AC output can be processed to provide position information. Position sensors can determine velocity by processing the data from two sequential position samples. The more direct method to measure velocity is to use a tachometer. A DC tachometer is actually a small generator that gives a DC voltage proportional to velocity. Optical tachometers give a pulse for each revolution of a shaft. Proximity sensors sense whether an object has arrived at a certain place. The simplest way to do this is with a mechanical limit switch. Other methods would include using a photosensor or a Hall effect switch. The Hall effect switch gives an output if a magnet is brought near a specially configured semiconductor. Load sensors can determine force by measuring the small deformation that the force causes. The traditional method for measuring large forces is with a bonded wire strain gauge. This device incorporates a pattern of thin wires. When stretched, the resistance of the wires change. Another method for measuring force uses a piezoresistive effect of semiconductors. That is, the resistance changes when the material is compressed. Pressure sensors measure the pressure of liquids and gases. One class of pressure sensors, such as bellows, use the pressure to cause mechanical motion. Semiconductor pressure sensors convert pressure directly into electrical resistance. A wide variety of temperature sensors are in use. Simple bimetallic strips will bend when heated and can then activate switch contacts. The thermocouple is a traditionally high temperature sensing device that makes use of the fact that the junction of two dissimilar metals will create a small voltage when heated. The resistance temperature detector, RTD, uses the fact that a wire will increase in resistance when heated. Numerous semiconductor devices are available that convert temperature directly into resistance or voltage. Flow sensors measure the flow of a fluid in a pipe or open channel. Many flow sensors work by placing a restriction in the pipe and then measuring the pressure before and after the restriction. The pressure difference between the two places is proportional to fluid velocity. Turbine flow sensors use the moving fluid to spin a propeller. The RPM of the propeller is proportional to velocity. Liquid level sensors determine the level of liquid in a tank. The discrete type can sense only if the level is at or above a certain point. Examples of the discrete level detectors are a float activating a limit switch or a photosensor. The continuous level detector gives an analog output proportional to fluid level. There are many different ways this can be done. For example, connecting a float to a potentiometer, monitoring the pressure at the bottom of the tank, or monitoring the weight of the tank with load cells. Vision sensors are being used more and more for such things as inspecting parts and guiding robots in assembly operation. A vision system consists of a camera connected to a computer. Special Vision software analyzes the video image and makes specific recommendations to the work area. That brings us to the end of the section on sensors and transducers. Again, just an introduction to scratch the surface, and this is something which would bear future research. Please look on Blackboard for the homework and get hold of me if there are any questions. Thanks.